Let's do section 11.2, page 552, exercise 21, which reads, let vector u have components 3, -2, and let vector v have components -2, 5. Find the A component form and B magnitude of the vector. And for exercise 21, our new vector is 2u minus 3v, which I am going to call vector W. Now, as we've learned, we can only add together x components to other x components, and we can only add y components to other y components because x and y are independent of each other. So that tells me that the x component of my new vector is going to be 2 times ux minus 3 times vx. So that's going to be 2 times the x component of u, which is going to be 3, minus 3 times the x component of v, which is going to give me -2. So that's going to give me 6 plus 6, which is equal to 12, or the x component of my new vector is going to be 12. So we can do something similar with the y component of our new vector, and it's going to be 2 times uy minus 3 times vy. So that's going to give me 2 times the y component of u, which is -2, minus 3 times the y component of v, and that's 5. So this is going to give me -4 minus 15, which is going to be -19. And if I'm going to write this in component form, then I'm going to say that W is going to be that funky bracket, the x component, which is 12, comma the y component, which is -19. And this gives us our answer to part A. Now part B asks us to find the magnitude of this new vector. So the magnitude of W is going to be the square root of the sum of the squares of the components. So that's going to be wx squared plus wy squared, or that's going to give us the square root of 12 squared plus -19 squared. And when we do that math, we get the square root of 505. And when you take that square root, you get approximately 22.5.